So what else can we do here? I like example one. I like example one. I like example one. Example one is a nice question. Why would I say that? Did you hear me say it was going to be on the test? Or are you just kind of the student that tends to notice when a teacher tends to emphasize certain stuff like that? Okay. We can figure out an awful lot with tiny bits of information. So I figure I can give you any one of these pieces of information and you can figure out the rest. So the first thing in the first row, I gave you the symbol, Mg. What is Mg? Sorry? Is it magnesium or manganese? Because you got to be really careful. I always get magnesium and Mn. Is it magnesium? Yeah. Okay. So really small. I didn't leave you much room. You can squish in here. Magnesium. Right? What's its atomic number? How many protons? 12. How many neutrons? Don't say 12. We have to do some math. How do we find the neutron? Is it 12? Yeah. But you can't assume that it's always the same. How did you get the 12, Cole? You went 24, take away 12. By the way, with your test in about a week or so, you probably want to bring a calculator, unless you're perfect at doing two-digit subtraction in your head. Then I'm good with that. So 12 neutrons. How many electrons when it's neutral? 12. How many valence electrons? Count from the left. 2. How many electron shells? What period? Same answer. This is the same. You can, if you want to, you can put a little arrow saying that's the same question, just phrased differently. What's its family number? That's from the very top. The numbers are on. Yeah. Okay. Family 2. We're going to add one more here. We're going to add a little column to the right called ion charge. What's its ion charge? When it becomes an ion, what charge does it have? And this is from the top right corner there as well. 2+. Okay. What if instead of giving you the symbol, what if I gave you the atomic number, the next one? 15. What's that? Sorry? Phosphorus? We'll call that one phosphorus. That's okay. Most of these are Latin or Greek or foreign names, so you kind of get a feel for it. Symbol? Capital P. How many protons? 15. How many neutrons? 16. How many electrons when it's neutral, when it's not an ion? 15. How many valence electrons? Count from the left. 5? Is it 5? 1, 2, 3, 4. Yep, I agree with that. How many electron shells? Or what period is it in? 3rd? What family number? 15? When it forms an ion, what's its ion charge? Is it 3 negative? Do you know how I figured that out in my head? I said, well, it's got 5 electrons. It wants a full valence shell, and in that row it wants a total of 8. It's going to gain 3 negatives, 3 electrons. I can give you the name. That's pretty easy. Argon. Symbol? AR? Atomic number? 18. How many protons? 18. How many neutrons? Got to do some math. 22? 32? I think 22. By the way, that's by far the most common mistake, is forgetting to carry the 1, which is why I recommend, even if you are good at mental math on the test, in your head, I would bring a calculator to the test anyways, just so I don't make that. That's what I mean when I say don't make mistakes. Because now you're like, oh yeah, of course it's 22, right? How many electrons when it's neutral? 18. How many valence electrons? 8. It has a full shell. And because it has a full shell, it's stable. It does not want to react. In fact, everything in that right-hand column has a full valence shell, which means either they don't want to react at all, or if we are going to get them to react, we have to do it in a lab and kind of add a bunch of energy and force it to happen. How many electron shells? Also 3, which means it's in the 3rd period. And it's family number 18, right? What's its ion charge? Well, you know what? It doesn't form an ion. It doesn't gain or lose electrons. Okay? Look up. We're going to add something to this next one. Where it says ion charge, we're going to add -1. And where it says number of electrons, we're going to add 10. Now, how is that possible? Let's walk through this. First of all, how many protons? 9? Or is that a German student saying no? 9? No? 9? 9? No? 9? Okay. Zing! Over. He just figured it out. You got that, did you? Okay. So, how many protons? 9. What's its atomic number then? That's how it's defined. So I can fill that in. Oh, and I know what we're talking about. What element are we talking about then? Fluorine. Which is F. Fluorine. How many neutrons? 10? Now, I made this up. I said it's got 10 electrons. You know what that tells you? Is the number of protons and electrons the same for this atom? Nope, it's not neutral, it's an ion. It's become an ion. It's gained an electron, probably from a metal. Some metal somewhere wanted to get rid of an electron. It said, I'll take it. Okay. How many valence electrons? Well, because this one is an ion, normally fluorine would have, count across, 7, but it's gained an electron. How many valence electrons does this have? Ooh. How many does it normally have? Count across? 7. It's just gained an electron. It's got a full shell of 8. How many electron shells? 2. What period? Also 2. Family number 17. Family number 17, by the way, has a special name that I said was worth remembering. I think it's on your, yeah, the halogens, yeah. Okay. By the way, halogens, they have some neat properties when you apply electricity to them. You may have heard of halogen lights. Those are halogen gases in some of the street lamps. Although we're slowly replacing the street lamps. You may recall when you were growing up, street lamps were kind of a silvery, bluey, purple color. And now you may notice they're an orangey color. We're replacing them with sodium lamps because they last longer and take less electricity. You guys have noticed that street lamps have changed as you've been growing up a little bit? You guys didn't notice that at all, did you? Oh, man, be observant. Hey, what if you got 16 electrons and you're neutral? What element are we? Sulfur? How do you know? What element number is sulfur? Okay, so let's go 16, S, and sulfur. And I think I said in Britain, instead of an F, they spell it with a PH. So you'll see it spelled both ways in various documents. In fact, sometimes I flip-flop. Oh, atomic number 16. How many neutrons? Oh, it also has 16? Is it mass is 32? Yeah. Oh, okay. By the way, what you'll notice, Hannah, is the further down you go, the more neutrons you have, and the more unstable the atom is. The word nuclear comes from the word nucleus. So when you look at something like uranium, for example, which is way down, it's got so many neutrons in its nucleus, it's nuclear. We split the atom. We fire a neutron into the nucleus, and it causes it to break apart, and when it breaks apart, it gives off a bit of energy. You do that several trillion times, you have a nuclear bomb. But if you wondered, why does nuclear, where does that come from? Nucleus. You're splitting a nucleus up. Hashtag nerd trivia. Hey, what if you got 53 protons? Oh, and hey, we haven't finished yet. Sorry. Number of valence electrons in sulfur. It's neutral. 1, 2, 3, 6? Is that right? Yeah. How many electron shells? 3. Means it's in the third period, and it's in family number 16. Also an important family because what's right above sulfur? Oxygen. We kind of need that one. What kind of an ion charge when sulfur forms an ion? Its ion charge is 2 negative. Why? Is it 2 negative? Yeah. Why? It needs to gain 2 negative, 2 electrons to be stable. Element number, or 53 protons is going to be element number 53, which is what? Iodine, or if you're British, iodine. By the way, it's fluorine, it's chlorine. It really should be iodine, but it's bromine. But for some reason in North America, we say iodine. Symbol? Capital I, right? How many neutrons? How would you calculate the number of neutrons? What take away what? 127 take away? So 127 take away 50 is going to be 77 take away 3. Is it 74? Someone double check me. 74? How many electrons? 53. By the way, you'll notice now that we move further down, Brooke, way more neutrons than protons. This is when you start to get radioactive and unstable and stuff like that. How many valence electrons? Well, now that we've gone further down, okay, we're actually not going to say that there's blah, 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 blah. As soon as you go past, let me get my periodic table out. Oh, I have it here. Here, periodic table. Oh, come on. As soon as you go past this row, I know it goes 2, then 8, then 8, then 8. It goes a little haywire because down here, you guys can't see my little cursor moving. Let's do that. Down here, the shells start to overlap and tangle, and there's subshells, and it gets very complicated. So you know what you do? You know how many valence electrons this has? It has 1, 2, 3, 4, 5, 6, 7. The system breaks down. I'm not going to ask you that. Did I say I'm not going to go past calcium on your test? Okay. I just did this one for nerd trivia. Is that okay, Mason? So once you get down here, what we're really going to say is it has the same number of valence electrons as the stuff in the top rows here. Where are we? More practice. Which actually makes it easier than counting all those. Oh, by the way, and the other reason, Hannah, you may have noticed is, you guys notice there's a break in the periodic table right there, and the reason is this electron shell holds a bunch of electrons in subshells, but we just can't fit all these elements in there. So otherwise our piece of paper would be like yay wide. So what we actually have, Josh, is a little break right there, and this arrow is saying, just imagine those are squeezed in there, and just imagine that row is squeezed in there, but we just can't fit that on a piece of paper. I don't think I ever mentioned that, but you guys probably figured that out anyways. Right, Alex? Sure thing, right? Let's fit. Oh, so what did we say? How many valence electrons? 7? Is that what I said? I think. 7. How many electron shells? 1, 2, 3, 4. Is it 5? It's period 5, family 17, and it forms a -1 ion. Hey, what else could I ask you? Suppose an element has 80 protons and 120 neutrons. What will its mass be?
200.
What element is this, by the way? Mercury. Hey, wait a minute. What is the mass of Mercury? 201? And I said 200? You know what? Sometimes it's missing a neutron. It's called an isotope. So that's why I made this one up. Hey, what element is this a model of? So now we're going to talk about Bohr models here. How can you figure out what that is?
20 protons and 20 neutrons.
So 20 protons tells you what? Oh, calcium?
Yeah.
Is this an ion or a neutral atom? Well, let me double check. I have how many electrons in my outer shell, in my valence shell? 2. This is an atom. Now, if it was an ion, what you would notice is those wouldn't have been drawn. It would have gotten rid of its 2 outer electrons. Now, usually the way we signal that as well is we try and put square brackets and the charge around there. That's to let the marker know I didn't forget the electrons. I did it on purpose when I was drawing this. But that's the difference between an ion and an atom. Hey, what's this a model of?
Carbon.
Let's see. How many electrons? So how many protons if it's neutral? 6. So you're telling me it's element number 6? Carbon? I agree. Is carbon 6? Okay. What ion is this? How do I know it's an ion? Square brackets, and they put a charge of +1. Looking in, did the nucleus photocopy okay? How many protons are there? So what element is this? Normally lithium has how many electrons? 3. How many electrons do I have here? In fact, lithium got rid of that. By the way, this is why lithium is used in those lithium-ion batteries in your phones. It's very good at getting rid of, it really wants to get rid of an electron. It's very, very happy to pass electron electricity, right? So this is one of the reasons why we use lithium in batteries. The only problem is lithium is also naturally reactive. The batteries can explode, so if you drop your phone, be careful, be cautious. So this would be a lithium plus ion. Why plus? Because there's a little, see the little plus right there? How many electrons in its valence shell? 0. That's why I did add that extra circle to show you there was a shell there, but it's gone. It got rid of it. So don't tell me it's got 2 electrons in its valence shell, because those 2 electrons are an inner shell. Is that okay, Nick? A couple more, we're done. Hey, what ion is this? So we would write this as O2 negative. Did oxygen gain or lose electrons? It gained. How many? 2. How many electrons does it have in its valence shell? 8. Okay. Last thing and we're done. Draw a calcium atom and a calcium ion. Whew. Okay. Calcium atom, how many protons? So 20 Ps. How many neutrons? Also 20? Oh, lowercase n is what I've been using for neutron, haven't I? What period is it? 4th? That means the first 3 shells are full. If it's in period 4, the first 3 shells, the 3 inner shells are packed. I've memorized this from the periodic table, so I can almost, without thinking about it, Carter, say, oh, I'm going to have 2, then I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. There's the first 3 shells. Do you see how we can use that as a shortcut, Mandy? Okay. The 2, 8, 8. How did I get the 2, 8, 8? On your periodic table, 2 in the first period, 8 in the second period. 8 in the third period, 18 in the next period, but I told you I'm not going to have you draw something that big. How many more electrons do I need in my valence shell? You're right. Okay. I can't draw circles. 1, 2. There. Shut up. It's a circle. It doesn't like, calcium doesn't like this situation. It's got those 2 extra electrons. It really wants to get rid of them. So when it forms an ion, what will an ion look like? Well, still 20 protons, still 20 neutrons. Still 2 in the inner shell. Still 1, 2, 3, 4, pair, 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 pair. They start pairing up after 4. By the way, that's why you'll notice I didn't pair these guys up. I would pair these guys up once this shell was oh, it's going to have 1, 2, 3, 4, 5, 6, 7, 8. How many in its valence shell if it's an ion? This is its valence shell right here. So here's its valence shell. How many will be in its valence shell? If it's an ion, 0. It wants to get rid of those 2 electrons. Now, I drew a blank valence shell in. You can if you want to, Drew. I'd also clue in if you just did that. Except right now, this looks like a typo. This looks like a mistake. To show that it's an ion, to show that we did this on purpose, Nick, we say, oh, and we put its ion charge, 2+. Does that make sense? Does that kind of review kind of everything we left off with? So what I have for you, first of all, if you haven't finished off the homework questions from last day, these ones, see if you can get those done in about 20 minutes. But I got a little bit more practice for you. 2 things.